In today's lecture, we are going to talk about intertemporal choice. It's such an important topic when it comes to economics. Specifically, you must have encountered this topic in microeconomics, but it's very much possible that you encounter this topic in macroeconomics when you're discussing consumption theory. So, particularly when you're discussing consumption theory and you're talking about micro foundations of macroeconomics, sounds tricky, but yeah, then you might encounter this particular topic once again, which is intertemporal choice. So it doesn't matter whether you are watching this video with the perspective of learning from microeconomics or macroeconomics, learn it anyways because it will be helpful when you discuss in any of these branches of economics. So talking about it, intertemporal choice. What does this even try to put forth? Well, we have already discussed about budget constraint. We know, as economists, we understand what is a budget constraint. As economists, we understand what is an indifference curve. So often, of course, we are not going to, delve deep into understanding those bits and pieces. But the question is, imagine that a consumer is living for 2 periods. So imagine your lifetime is being divided, is being chopped off into 2 periods. One is your current period, and the other is your future period. You are not going to survive after the future period, that's all. So whatever you want to do, just do it in this 2 periods. You don't have anything else to start with or to end with. So if you have only 2 periods, how would you behave? Does your consumption today, what you consume today, is it only dependent on your current level of income, or also it depends on the future earnings? Let me put an example here. Whatever I'm consuming, whatever standard of living I'm trying to maintain, be it in terms of what kind of air condition I use in my house, what kind of bulbs I use in my house, what kind of dresses, what kind of clothes I wear, aren't all these dependent on not only my current income, but what my thought is about the future earnings that I'm going to receive? So I might be earning, in Indian currency, let's talk about, I might be earning 10,000 rupees per month, which is very, very small if you talk about in today's scenario. But it's very much possible that, I might consume 12,000, 13,000, even though I'm earning 10,000. It's just because my consumption today is not only dependent on my current income, but it is also dependent on what I'm going to earn in the futures. The idea that consumers always try to smooth out their consumption. The consumption smoothing concept comes out again and again when we are discussing intertemporal choice. People try to smooth out their consumption. So if I, give you some money, you are not just going to utilize this money for today's consumption itself, but you will also try to save a little and spend it out in your future. This behavior persists in human beings. This is very common for all of us. So people always try to spread out their consumption with the different incomes that they are going to receive throughout their lifetime. And intertemporal choice just tries to talk about that. But before going into that subject, before going into this intertemporal choice, we must be very, very clear with some basics. And one of the basics that we often talk about is the concept of present value and future value. And it might sound a very tricky concept, but trust me on this, it's a very, very simple concept, extremely simple. Let me give an example. Suppose I have 100 rupees today. All right, what can I do with this 100 rupees? I can put this into a bank, and suppose the bank is offering me a rate of interest of 10%. So tell me, after a year, this is 10% per annum, after a year, what this 100 rupee will become? Will it just be 100 rupees? Not exactly, because this principal 100 rupees which I'm going to invest in my bank will also have some interest which will be accommodated with it. Therefore, my total amount that I'm going to receive in the future is going to be definitely greater than 100 rupees. So, if I ask you that this 100 rupees, how much will it turn out to be? You will say that, well, of course, you're going to get this 100 rupees for sure. But apart from that, over this 100 you would also get a 10% interest. So if you just look, I can take 100 common. The formula looks something like this. No? And what is this 10%? It is nothing but the rate of interest. So this principal, this amount, this money will become this much in the future. This money will become this much in the future. This is the future value of my today's income. Sounds tricky. My today's income will become this. So therefore, this is the future value of this 100. This is the future value of this 100. Understood? If you calculate this, this comes out to be 10. Therefore, 100 plus 10, which is 110. So I can definitely say that my current income of 100 will become 110. So my 100 rupees has a future value of 110 rupees. Understood? So if you want to convert the present value into future value, what you need to do is you need to multiply with something which is known as the discounting factor. If you see, I just multiplied this current income into the discounting factor, and therefore I got my future value. Alright. Now think about it in a reverse order. If I ask you that 110 rupees in future, how much is it worth in present? It is 100. Well, this concept sounds very tricky, but it's not actually. Let me put it in a different way. Let me frame it in a different way, and maybe then you will catch it up. What I'm trying to say, please listen carefully. What I'm trying to say is, this 110 rupees, how much is it worth now? Because this 110 rupees will be achieved by me after a year. So what do you choose? Money after a year or money now? Money now, right? So this 110 rupees is worth 100 now, which means that if I ask you, I'm giving you 100 rupees now, all right? And then I say you, I'm giving you 100 rupees a year later. Your argument should be, if you are a rational human being, your argument should be, I'm indifferent between the two, because actually both are the same thing. Giving 100 rupees now versus giving 110 rupees in the future after a year is actually the same thing. So this 110, how much is it worth now? It is 100 rupees. Well, you might think, well, why will this be the case? Answer is pretty simple. Because what you can do is, if I have 100 rupees now, I can put it into a bank, and therefore I can earn an interest over it. Therefore, my earning after a year would be 110. So definitely there is no doubt about it that my future value of 110 is actually worth 100 rupees now. So if you have ever learned in your childhood about compound interest and all, you must have, undergone these two words, principal and amount. It's simple to that. It's just that. What I am essentially saying is 100 rupees now, the principal amount, is equivalent to getting 110 in the future, because if I have 110 now, please understand, 100 rupees now is equivalent to getting 110 in the future. Why? Because if I have a 100 rupee note now, I'll just invest it out there, and therefore I'll earn after a year 110. So basically, either give me 100 now or give me 110 later. It doesn't matter. So just think it opposite way. If you are converting the present value into the future value, you are multiplying with 1 plus r. Think about it here. You have the future value right here. You have the present value right here. If you want to go back, just take the future value, which is this, divide it via 1 plus r, and therefore this gives you the present value. So when you are going back to the present value, you are actually dividing by 1 plus r. Here you are multiplying. So just think it this way. If I have a certain amount of money now, if I invest it into a bank, that bank will offer me certain amount of rate of interest. Therefore, after a year, that future value is going to be higher. Then think it in the reverse order. Getting some amount in the future is equivalent to getting a lesser amount currently. If you are going to get 110 in the future after a year, I mean, it's equivalent to getting 100 now, because a year is also a lengthy time. If you have it now, you can invest it, right? So this is what the concept is, and you wouldn't, clear this yourself unless and until you think of an example. You try explaining it to yourself. Just sit down, switch off this video for now, and try repeating the example. You will see there would be some sort of a euphoria movement where you will understand things. And this is, this is my guarantee. All right. Now, keeping that in mind, let us discuss about intertemporal choice, because I think that you are clear with this. So always remember that if we are trying to get present value of something, we are going to divide by the discounting rate. And if we are trying to go to the future value, we are going to multiply by the discounting rate. Understood? So intertemporal choice starts with the idea of two-period model. In the two-period model, we assume that there are only two periods, which are current period and future period. The consumption in the current period, well, I'm going to represent that by C1, and the consumption in the future period, I'm going to represent that by C2. Alright. And what I'm essentially saying is, please listen to me. This is very important. What my budget constraint is in the two different periods. Budget constraint in period 1. I'm writing P1 as period 1. Suppose I'm going to, period 1 is the current period, right? I'm going to earn Y1. And the budget constraint that I have is that Y1, this amount of income that I'm going to receive, either I can consume a portion of it or I can save a portion of it. And please remember, this saving could also be a dissaving. What do I mean? Please remember, this is very important. When I'm saying S1, it means it is the savings which I'm doing in Y1 period, and I don't need to write S1, I just can write S, because you'll see in a while writing S1 doesn't change anything, because in second period I'm not going to save, because I only live for 2 periods. I'll talk about it in a moment. I'll explain each and everything, but please understand, Y1 equals to C1 plus S1. This is what I'm saying. This S1, what is it? This S1 represents savings or dissavings. It could be representing anything. If this S1 is a positive number, so if you have earned 100 rupees, say, and you consumed 80 and 20 remains, and this 20, what you're doing? You're saving it up. So this saving is positive. So it could be positive 1, or it could also be the case that you are earning 100, but you are spending 120. You're consuming 120. Well, you might think that how is this possible? Well, this is possible because you might borrow from your second period. You might be a borrower. Please understand that I'm not talking about borrowing from somebody else. I'm just talking about borrowing from your future self. Borrowing from your second period's income. It might be the case. So your S1 can also be negative. If it is a saving, positive savings, of course it's going to be a positive one. And if it is negative, it means that you're talking about dissavings. Got it? It's not important right now what this value is. Rather, we can just have anything. Alright. In the second period, however, budget constraint in period 2, your income Y2 would be consumed, would be equivalent. So budget constraint always means, or I would not say even budget constraint, budget equation I would rather say, not constraint. Constraint means you have to spend within the limit. I'm talking about budget equation. So please understand, in the second period, you have to spend entire income. Can you tell me what is the entire income that you have? So please understand, in the second period you have what you are earning in the second period itself. You are earning certain amount in the second period, that is going to be a part of your income. But if you saved in the sense that you saved it in a bank, suppose, with a certain amount of rate of interest, well, that amount is also going to mature. That will add to your second period's income. So your S1 is going to mature, suppose, into R. What do I mean? I mean, suppose that you saved 100 and bank was offering a rate of interest of 10%. It means that your 100 into 1 plus 10%. You know what it is. It is a future value of your savings done in the period 1. When you saved 100 rupees in period 1, your savings turned out to be 100 into 1 plus 10%, 1 plus certain amount of R, which will be 110. So whatever you're going to earn in the second period, that will form your part of income, but also what you saved in the first period would also be a part of income. Your question might be that what if I didn't save? I was a borrower. I borrowed. I consumed too much in my first period and I borrowed. Well, then you must have borrowed, therefore you must have to pay certain amount of rate of interest. So how much amount of interest that you're going to pay? Again, this S1 in itself is going to be a negative value. Suppose you borrowed 100. So 100 along with the rate of interest, therefore you have to return back 110. That would be subtracted from your income. That's not a matter of concern for now. Please understand what this particular thing means. Please understand that you cannot save in the second period because you only live for 2 periods. When we save for a certain period, we assume that we are saving for future. Well, there is no future after second period in our model. So you're not going to save. And you might wonder that, I am going to save for my children. Well, first of all, we are assuming that there is only one consumer in the economy. And that consumer acts as a representative consumer. He is a representative of the entire society. That is what micro foundation of macroeconomics seems to be. Alright, so please don't think about all those things. I mean, that's a very genuine question, so as to speak. But Y2 plus S1, 1 plus R. Alright, now you are going to consume entirety of it. So whatever income you have in the second period, that will be equal to the consumption in the second period, because equation means what? You're spending the entire thing which you have. Nothing, is being saved. Therefore, because you're not saving in the second period, you might as well write this just as S, because there is no S2 in the future. There's only going to be a possibility of saving in the first period. Second period you can't save. So therefore you could write just S, but it's in my habit that when I'm mentioning about first period, I use the subscript 1. Therefore I'll use it. You can avoid it as well. Now, if you know so total consumption in 2 periods must equal total income in the 2 periods? No. Total consumption in the 2 periods must equal total income in the 2 period. Therefore, what I can say is the consumption, writing this as equation 1, I'm writing this as equation 2. Can I say equation 1 is rewritten as Y1 minus S1 is equals to C1, or I would rather say like this. S1, what is it? What is savings in itself? Savings is nothing but income minus consumption. Out of income, whatever you consume, just you subtract that, what remains is saving. I'm just using this as the equation and substituting its value in this equation number 2. So substituting the value of equation 2, equation 3 rather I would say, in equation 2. So Y2 plus, in spite of writing S1, I could just use this in brackets. Okay, I'll open the brackets. So y2 plus y1 with the entirety of this thing minus c1 into this. Alright, now what I'm going to do is I'll just put c1 on that side. So this is y2 plus y1 1 plus r, and this is c2 plus c1 1 plus r. This right here is in the future value form. You might ask, how are you so sure? I mean, what made you say like that? Well, the answer is pretty simple. This is, I'll just rearrange. I'll write C1, first period's 1 in the first, in front. I'll just rearrange everything. Y1, 1 plus R. Y2 plus Y2. C1, 1 plus R plus C2. This is the future value form. Well, why am I saying this? I'm saying this because you see, this is second period's income. This is second period's consumption. Alright. This is what my first period income will value in the second period. How am I so sure? I just told you that while converting present value into future value, we multiply with 1 plus R. So the present value of Y1, how much would it value in the future? If I have certain amount of income in the first period, how much would it value in the future? It will value Y1, 1 plus R. Y1, 1 plus R. Alright. And if I'm consuming certain amount of consumption, suppose 80 rupees, 100 rupees, whatever worth of consumption I'm making today, that consumption will be worth to how much? The amount, the consumption expenditure which I'm going to spend today, how much that amount will worth in the future. Had I not consumed, had I invested somewhere, how much would it worth in the future? So again, for that we'll just multiply it with the discounting factor. Right? So whenever we multiply the present value into some amount of discounting factor, that gives us the future value format. This is it. But some people like to write it, I'm just using this as here. Some people like to write it in the present value form. So what we are going to do is divide both sides by 1 plus R. So you have Y1 and 1 plus R is here. I'll just not skip this step because you might feel lost later on, and that is one thing which I don't want. You know one thing, if you have 2 plus 3 whole divided by 5, you can just split out things. You can write 2 by 5 plus 3 by 5. If you don't think that this is right, think about it in the reverse order. If you had 2 by 5 plus 3 by 5, you could just take LCM of 5 and 2 plus 3, right? So this is what I'm doing. Hence, I can just split it out. Y1, 1 plus R cancels out. Y2, 1 plus R is equal to C1, 1 plus R cancels out. C2, 1 plus R. So tell me, what is it? It is the present value form. How am I so sure? I'm just dividing it. This is what my current period's income is. This is how much the future income is worth today. How much the future income is worth today. Present value form. I'm dividing by something, right? This is how much my current consumption is. This is how much my future consumption expenditure is worth today. This is what it is. This is the future value form. Sorry, present value form. Previous one was the future value. So whenever you see something being multiplied, it means you're talking about in the future value form. And whenever you see something being divided, you're talking about present value form. It's that simple. Don't mess it up. Alright. So this is the equation which is also known as intertemporal budget equation or budget constraint, whatever. Intertemporal budget constraint or budget equation. Please remember, you might not realize what does this word intertemporal means. It means that this is a budget constraint, because essentially what is a budget equation? Budget equation talks about the income that you have and the consumption you're going to make. If you remember, when we talked about two goods, apple and orange, the income you had and the amount of consumption expenditure you're going to have on apple and orange. But here you're talking about two different periods. You are talking about the amount of income you're going to have in those two different periods and the consumption you're going to make on those two different periods. Let me repeat. Here you are talking about the income that you're going to have in the two different periods and the consumption expenditure you're going to make in those two different periods. So there is different time periods involved in the same structure. In the same structure, you're talking about two different time periods. That is why it is known as intertemporal. Intertemporal indicating in between two different time periods. Understood? This is the whole idea. Now, please understand, if I am going to plot this out, you have to take C1 and C2. Please understand, Y1 and Y2 are given amount. Y1 and Y2 are given to you. C1 and C2 is something that you have to choose. The whole idea here in this topic lies on the fact that what is going to be your optimal consumption bundle. How much consumption you're going to make in the first period and in the second period. How much optimal consumption you're going to make in the first and in the second period. So income is given to you. And if you're already given income, it will act as a constant. So our whole idea is not to plot income, rather our whole idea is to plot the consumption expenditure I'm going to have in these two different periods. Like for example, when we talked about apple and oranges, two different commodities, we didn't talk about the income that we had because income was given, it was a constant. We talked about the number of apples and oranges I should have which will maximize my utility. Here also, the amount of expenditure I should have in the first and the second period which would help in maximizing my utility. Understood? So here we are going to take C1 and C2. And you can work it out. It is just going to be a downward sloping equation. This is what it is. Can you tell me what will be the slope? Well, if you are confused, you should know that any line can be written in the general equation y equals to mx plus c, where m represents the slope. Now do one thing, just represent it in this manner. I'm just trying to write this in front. C1 plus C2, 1 plus r, and here you have y1 plus y2 divided by 1 plus r. Now what I'm trying to say is y equals to mx plus c. Whatever you represent on the y-axis should be written here, should be denoted on the left. Whatever you write on the y-axis should be denoted on the left. Please tell me, what are you representing on the y-axis? C2, just put it in the left, just let it stay on the left and put everything else on that side. So suppose C1 is put here, but because it goes there, it would be a minus C1. Y1, Y2 by 1 plus R. Please understand, R is given to you. Incomes in the two different periods are given to you. This acts as a constant, which is nothing but this C. What is X? X is the variable which you are representing on the X-axis. Please tell me, what are you representing on the X-axis? C1. So hence, C2, 1 plus R minus C1. And I'll just rub it off because I don't think that it will be visible. So I'm just writing here C2 1 plus R minus C1 Y1 Y2 1 plus R. So what I'm saying is I'll just multiply this 1 plus R whole throughout that side. So I'll just multiply everything. C2 equals to 1 plus R multiplied with everything. So it will be multiplied individually with each and every thing. Y1 1 plus R. And y2 1 plus r into 1 plus r, it would be just y2. So please understand, this is acting as a constant. In the general equation, you have C. Whatever is represented on the x-axis should be here. C1 is represented. Whatever stays in front of it is nothing but the slope. And there was a shorter way to find out slope by taking dc by dc2 by dc. dc2, what kind of language am I using? Differentiate consumption in the second period by consumption in the first period. So this is what you could use also. You could differentiate also to figure out the slope. But I just use this for people who are not, very much into mathematics, calculus and all. So what you have is this right in front, this y equals to mx plus c. This follows that structure where this is the constant, this is the x variable, and whatever stands in front is the slope. So this is the intertemporal budget line, and the slope of this line is minus 1 plus r. Minus of the discounting. Minus just comes out because it is a downward sloping one. I hope this is pretty much clear. Yeah. So this is the intertemporal choice. Any bundle on this intertemporal choice indicates that you can afford this bundle. Any bundle within on this intertemporal budget line or inside that intertemporal budget line indicates that you can afford that. Alright, so the utility function that you're going to choose is of this form. Utility, which comes from the consumption made in the first period, plus B. You could take rho as well. You could take any variable as you like. It is going to be acting, not variable, rather I would say any alphabet as you like. This will act as a constant. And what is it? I'll talk about it. This is utility, B multiplied with utility in the second period. B represents time preference. And it's very, very subjective. I'll talk about it. I'll give an example. And this B would lie between 0 and 1, indicating that it will be a fraction. So what does it even mean? Let me give an example. It's just human behavior. Some people value today's money more than, the same amount of money in the future. So if I give you 100 today versus I give you 100 15 days later, maybe depending on the situation you have right now, that 100 might be very, very needed to you. Therefore, you would prefer that 100 today. But 15 days later, you don't know. So 15 days later, that same 100 might give you a lesser utility. This is what the idea is. And it depends on individual. But it's very rational to think it that the delayed amount of, the delayed payment is done, or if you get that same amount of money in a much more delayed time period, definitely that is going to give you a lesser utility. So I'll just try to explain what does it mean. Suppose you have 100 rupees, you're making 100 rupees of consumption on, so what does it mean? I'll just explain it also. This 100 rupees of consumption, you're going to buy composite goods. You're going to spread this 100 rupees into various goods. You're going to purchase those goods. You'll consume those goods, and therefore you will derive utility out of those goods. Fair to say? Now understand, because when you spend 100 rupees in the period 1 on consuming certain items, you would definitely get a utility out of that 100. The amount that you spent, suppose the utility that you got was 1000 utils. Just a random number I chose. But suppose after a year, you are spending 100 rupees again, but because after a year you are not purchasing exactly the same amount of goods and services you needed right now, maybe the preference for the goods and services you wanted just right now was way too higher. So after a year, that same 100 rupees, it's going to give you, suppose, only 990 utils. So the idea is that there is a preference in an individual related to the time. He would prefer a consumption expenditure being made today than in the future, and that amount is going to be accounted by or adjusted by this beta constant. Alright, don't think too much about it, but this is what it means. Just sit with it. Alright, now we also chose this additive form in order to explain that the utilities that I'm going to derive in the two different time periods are independent on one another. So how much of utility I'll derive in time period 1 through consumption is independent on whatever utility I'm going to derive in the second period. So this independency is captured by the additive form of utility function. Okay, just keep that in mind. Now, what we are going to do is, whole idea is, we have the budget line equation, the intertemporal budget line equation, which we saw. What did it look like? in the, suppose I'm talking about in the present value form. So it was C1 plus C2 by 1 plus R, Y1 plus Y2 by 1 plus R. Now, what I could do is, I could well write it in the future value form, but okay, I'll just do it this way. C2 plus 1 plus R, just let it stay here on the left side. Put C1 on that side. Y1 plus Y2 by 1 plus R is here. And put that there. So 1 plus R, of course, minus C1. Whatever we did to figure out the slope, the same type of method I'm going to use here. 1 plus R into 1 plus R is going to. So what I'm going to do is, I'll just write this as equation 4, and I'm going to replace this value in this consumption equation, because straight up using Lagrange multiplier to maximize this utility function might be a little trickier task. Yes, you could set up a Lagrange and follow out this and figure out the first order conditions and then go ahead, but that would be much more tricky to understand. Rather, let's do one thing. Using the budget equation, let us solve for C2 and just replace it back into this equation, and just maximize this equation as an unconstrained maximization problem. Because this C2 accounts for all these adjustments, and this would be something which will be later used as well, so let us keep that intact. So use C1 beta utility of C2 and this entire thing and our whole idea is to maximize this, because we'll have just one variable to solve for. Everything becomes pretty much easier. So maximize, we'll just try to I'll write it here, maximize this with respect to C1. So what I'm going to do is, we are going to differentiate this entire thing. I'll not write anything because I'll have to rewrite everything. I'll just differentiate this entire thing with respect to C1. So because we have not specified any utility function here, so we are just going to write U dash C1. I hope you know that U dash represents marginal utility that we derive from consumption in the first period. A unit increase in the consumption in the first period. We have beta here. Now you will have U dash, this entire thing. Please understand. You will have U dash, this entire thing. But don't forget that this entire thing was equal to C2. You are going to use chain rule. So if you had utility of x comma y, sorry, x into y, you would first write U dash of xy, and then you would again try to differentiate this. Similarly, what I'm doing is, beta is of course a constant. I'm going to have this utility U dash, and this entire thing was C2. And the chain rule which I'm going to use is that I'm going to differentiate this entire thing with respect to C1 once again. Please understand what I'm trying to do. I'm going to differentiate this entire thing with respect to C1. First, I'm differentiating this with respect to C1, U dash C1. Then B is common, of course. Then U dash. This entire thing is C2. Then I'm going to apply a chain rule. And in the chain rule, everything vanishes because this will just turn out to be 0. It is a constant. And here you have C1, but C1 differentiating that with respect to this, it will be 1. But this will be a constant which will come out like that with its sign, of course. This is the first order condition, and the first order condition has to be equal to 0. So you have U dash C1 beta U dash C2, and okay, one thing I'm doing right here, plus minus minus, all right. I'm going to push it that side. And what do we have here is U dash C1 by U dash C2 is equal to beta 1 plus R. This is something required, but what you saw right this in front of you, this is very, very famous. It is known as, and it is important also, this is known as Euler's equation. And it is through the Euler's equation that I derive this, which has another importance, which I'll talk about it in a moment. Rather, B was here, I would try to use this B right here. This thing is very, very important. What I did was I just pushed it there, and U dash C2 was pushed here along with B. So 1 plus R remains. This, which I derived nothing but from the Euler's equation, is pretty much important. You'll see in a while why. But what is this Euler equation is all about? I'll just rub this entire thing and focus onto that. So U dash C1 is equal to beta 1 plus R U dash C2, which is known as Euler's equation. Very, very important. You see, Euler's equation talks about the marginal benefit and the marginal cost you are going to face with due to consumption smoothing. Let me explain. Please understand that suppose my consumption, you know one thing, you know the diminishing returns and all. Okay, please understand that marginal utility, which is represented by U dash, is negative. What does negativity means? Negativity simply means here that as I consume more units of a commodity, the marginal utility is going to fall. But you know one more thing, that the double derivative is going to be positive. This is something that we have already learned in micro. I'm not going to repeat that. But this is something to focus on, that as you consume more, the utility that you derive from each extra units of consumption falls. The diminishing marginal utility concept, you know about it. So if I am consuming more, this U dash represents marginal utility, by the way. If I am consuming more, the utility that I'm going to derive from each extra unit of consumption is going to fall. As consumption increases, utility falls. Vice versa is also true. If I am consuming less, the utility that I'm going to derive is going to increase. If I'm consuming less, if I'm consuming more, the utility that I'm going to derive from each additional unit is going to fall. That is pretty much understood. Think about it in the reverse way also. If I am consuming less units, I'm going to get a higher utility out of it. Let me explain how. You consumed first ice cream, which gave you a marginal utility of 10 utils. You consumed the second ice cream, it gave you marginal utility of 5. So if you consumed more, you got a lesser satisfaction. If you consumed less, you got a higher satisfaction. Understood? So as you consume each extra unit of a commodity, the marginal utility is going to fall. Vice versa is also true. So if your consumption in the first period falls, suppose you're consuming less in the first period, so therefore the marginal utility is going to increase. Consuming less in the first period means your marginal utility is going to increase. So this marginal utility is going to increase. What Euler is suggesting is, since you consumed little, please, this is very, very important. Since you consumed little, you consumed lesser, you saved a certain amount of income. That certain amount of income, when you saved it, when you invested it, you got a return out of it. You got an earning out of it in the second period. That helped you to consume more in the second period. Because you consumed more in the second period, your marginal utility in the second period falls. Because you consumed more in the second period, your marginal utility falls. So this increment in the marginal utility in the first period is set off by the marginal utility in the fall in the marginal utility in the second period. So this is something really important. I'll spend 5 minutes time to completely make you understand this. The importance of the Euler's equation is pretty much very, very important, very, very intricate to this intertemporal choice. what I am essentially saying is, what Euler is saying is, always remember, as you consume more, the marginal utility falls. As you consume less, the marginal utility increases. So suppose, let us take case 1 where you are consuming less in the first period. So therefore your marginal utility has increased. But because you consumed less, you could save a certain amount of money. Because you could save certain amount of money, invest it, and therefore that helped you increase your income in the second period, which helped you to consume a part of it in the second period. So therefore consumption lesser now helped you to consume more in the second period. So when you consumed less now, your marginal utility increased. But this less consumption resulted in a higher consumption in the second period and fall in the marginal utility in the second period. So this marginal utility is being set off, consumption smoothing. You know that I'm going to consume less now. My marginal utility is going to rise. But you also know that this lesser consumption would be used up by me in the second period. Therefore, my marginal utility is going to decline in the second period. There would be a balance. There would be a set off. Think about it in the reverse order as well. Suppose you consumed more in this period. So consuming more means your marginal utility falls. Because your marginal utility falls and you consumed more, consuming more indicates what? You saved little, maybe you did not save, you borrowed. Because of that, maybe you borrowed. Suppose you consumed too much, you borrowed. Because you borrowed from the second period. You're borrowing from your future self, you're borrowing from the second period. That lowers your income availability in the second period. Therefore, in the second period, you will have to consume lesser. As you consume lesser, your marginal utility would rise. Again, there is a balance. This is what Euler's equation talks about. And it's very clear, very evident that this balancing effect is going to be dependent also on what is your time preference, how much you prefer holding a current consumption, doing a current consumption rather than doing it in the future. And it is also dependent on the amount of discounting rate which is available to you. But there's also one important thing. If I draw the indifference curve, the intertemporal indifference curve, C1 and C2, the indifference curve looks something like this, like the usual shaped indifference curve. But however, you should be thorough with it that C1 and C2 are the two axes which I'm taking. And the marginal rate of substitution, the name of the slope of the indifference curve is going to be minus is always going to be there, minus of the utilities, marginal utility. If you remember MUX by MUY form, when you had two commodity case, here you have two period case. So marginal utility in the first period divided by marginal utility in the second period, but there is also going to be a B here. When we differentiate the utility function, we get a B here. If I show it to you, the